Fractional exponents are really, really weird, okay? What you do with them is really, really easy to explain. But when you write it out, they're very strange. Because you all know what 9 squared means, don't you? What does that mean? That means 9 times itself twice, correct? And 9 to the third would be 999, right? 9 to the fourth, 9999. Yeah? Easy peasy. Now we've already come across one situation where it doesn't make sense, right? 9 to the negative 2. That makes no sense until you write it out and explain it, yes? Everybody cool? All right, now, 9 to the 1/2. What does that mean? 9 times itself, how many times? Half a time. That makes no sense, does it? The one guess that you could be, well, couldn't it be 9 times 1 times 4.5? Right? Because 9 times 9, half of 9 is 4.5. 9 times 4.5, right? So if that were right, 9 times 4.5 equals 40.5. Does that make any sense? Because 9 to the half is less than 9 to the 1, isn't it? Because a half is less than 1. 9 to the 1 is 9. So 9 to the half must be what? Bigger or smaller than 9? Smaller. It has to be, doesn't it? Because as exponents get bigger, the numbers get bigger, right? So it can't be 9 times 4.5. Can it? So what we're going to do is, I'm not going to explain why, because why is taking too long, and this is not that important. I am going to ask you to use your calculator to find this answer. So that is 9 exponent bracket 1 divided by 2, because that's 1/2, close brackets equals, and tell me what you get. 3. Now do the same thing with 27. 27 exponent bracket 1 divided by 3 bracket equals. And tell me what you get. 3. And then finally do the same thing with 625. 625 exponent bracket 1 divided by 4 close brackets equals. And what do you get? 0.5. 5. Okay? It's, trust me. Everybody cool? Now, stop for a minute and look at the numbers involved here. What do you see? You see a 9, you see a 2, you see a 3, and you see a 1. Now, we are dealing with radicals and exponents, yes? Do we ever, or rarely, do we ever write the number 1? So it's done. Can you think of a relationship between 9, 2, and 3 using exponents? Shaylee. 3 squared equals 9. Cool? Is everybody okay with that? Everyone sees that, yeah? Can anybody think of another relationship between 9, 2, and 3? Not 9 divided by 2 equals 3. Something to do with 9 will get us to 3. What? No, because 9 divided by 3 is 3. Can you think of something else? Square root of 9 is 3. Now how would I write square root? Index of 2, square root of what? 9 equals 3, yes? Is everybody cool with that? Now we just also found out that 9 to the 1/2 equals 3, doesn't it? Does everybody agree? We just did that with our calculator, yes? Now, if this equals 3 and this equals 3, then what do I know about the square root of 9 and 9 to the 1/2? What are they? Equal. Now, please notice, the index is the denominator. Does everyone see that? And the whole thing, if I were to give it an exponent, what would it be? The exponent that we never write. 1. The numerator became the exponent. Does everyone see that? Now, if it happens once in math, it probably happens more than once, doesn't it? Well, let's check. 27. Is the cubed root of 27 3? It is, because 3 times 3 times 3 is 27, correct? And we also know that 27 to the 1/3 is 3. Don't we? We just found that out with our calculators. So what does that tell us about these two things? They're equal. The denominator went to the index, the numerator went to the power. Does everyone see how it works? Do you think it matters what the fraction looks like? No, not even a little bit. So let's turn our page over and see if we can figure this out. So let's look at A. It looks weird, doesn't it? Because it's got a fractional exponent. But we know how to deal with that. Where does the denominator go? You just wrote this down like 1 second ago, guys. Where does the denominator go? Huh? It is the index. Denominator equals index. So, what is the denominator here? 2. So I'm looking for a square root. Yes? Right? The base equals what? We just did this 2 seconds ago. The base became what? Does anybody remember the proper name for that? Radicand. The base becomes the radicand. 0.04. Yes? And the numerator becomes what? We just did it. What did the numerator become? The exponent. So what number is going to be the exponent here? 3. Now we simplify. Does 4 have a square root? It's 2. So does 0.04 have a square root? What is it? Not 0.02. 0.2. Because this is the square root of 4 over 100, isn't it? Right? 400, 4 over 100, yeah? Square root of 4 is what? 2. Square root of 100 is 10, yes? Yes? And 2/10 is 0.2 cubed. Everyone okay to there? Now, 0.2 cubed is 0.2 times 0.2 times 0.2, isn't it? Right? What's 2 times 2 times 2? 8. But I need how many decimal places? Every time I multiply, I need a new decimal place, don't I? And I've multiplied how many times? 3 times. So how many decimal places do I need? 3. 1, 2, 3. What goes in the holes? Zeros in our number system. Is everybody good? That's a really hard one to start with because it's decimals. But that's why I like to start with that one. If people are even the beginning of good here, they're ready. Are people at the beginning of good here? Are you at the G in good? Yeah? All right, let's look at the second one. Here's all our rules. So, start with the denominator. What does it become? Index. So I need a root sign with what number? 3, which means I'm looking for a cube root. This is what we just reviewed, so I'm looking for a group of 3, yes? The base becomes the radicand. What's the base here? 27. And then the whole thing gets the power of what? 4. Everybody cool? Can we simplify 27? It's 3 times 3 times 3, isn't it? Is that a group of 3? So it comes out. Did we leave anything under there? No. So this is 3 to the 4th, which is what? 3 times 3 times 3 times 3. You might need your calculator. 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Does everyone see how it works? If you know these 3 things, can you do this? Yes. Oh, yuck. What do I do here? Remember how I said sometimes you have to put all your exponent laws together? What do exponents do over brackets? Multiply. What is 2 times 1/3? No, really?
I don't freaking know.
This dice is 1/3. Now multiply it by 2. 2/3. Okay. So what does this become? 8 to what power? 2/3. Now you already know how to do this. What does the 3 become? The index. What does the 8 become? The radicand. And all that is to what power? 2. Do we know the cubed root of 8? 2, because it's 2 times 2 times 2. Vanessa, I'm looking for a group of 3, yes? Do I have a group of 3? 2, 2, 2. So it comes out. Did I leave anything under there? No. So this answer is 2, because there's nothing left under the radical sign, and 2 is going to be squared. What is 2 squared? 4. And we're done. Is everyone okay with the simplest way to do this?
Apparently not.
Okay? Is everyone good? Now, do you think the rules change if it looks different? No. But it's more difficult to do if you don't know how to make it look like what you want. Understand? So let's look at this. Where does the 2 go? Index. So I'm looking for a square root, yes? Of what? 0.49 to what power? 1. Do we ever write 1? So we're done with the brackets and the exponent, aren't we? All I need is the square root of 0.49. Now, a lot of you have trouble with this because you don't actually understand multiplying. What's the square root of 49? 7. So I know this answer is 7, but I have 2 decimal places here. So how many decimal places do I need in my answer? 1. So it is 0.7. Because 0.7 times 0.7 would equal 49 with 2 decimal places. 1, 2. 0.49.
This would be helpful.
Yes, knowing your times tables is very helpful. The other way you can remember this is the square root of 49 over what? 100. Square root of 49 is 7. Square root of 100 is 10. 7/10 is 0.7. Are we all cool? So we know how to deal with decimals as a base, yes? Well, the only other place a decimal can show up is in the exponent, can't it? This is ugly, isn't it? But what is it really?
Root 4 on the inside.
3 over 2. Because 1.5 is 3 halves, isn't it? So isn't this 16 to the 3 halves? And then isn't it easy? Where does the 2 go? Index. So I need a square root of what number? 16. And the square root of 16 is going to be to what power? 3. What is the square root of 16? 4 to the 3rd power. What is 4 times 4 times 4? 64. Everybody okay with fractions? All right. Now look at F and try to do it completely by yourself while I have a mouthful of rice pilaf. Because you have everything you need to do that on your notes page right now. Yeah, I think so.
Good.
Yep. Would anyone like to take the lead?
Oh, I got this.
Okay, Bryce, hit me.
Alright, so it's 8.
Whoa!
Wow.
You still working? Okay, cool. Keep it in your head, Bryce. Let's talk. How are things?
Not bad. And yourself?
Not too shabby.
Oh.
What's your take on the Flash and Aquaman and Cyborg? Do you think they're going to make a movie for each of them?
No. Probably not.
Or are they going to go straight to Justice League?
Probably Justice League. No one really. Aquaman has a bad light now.
Yeah, I think so too. I don't think I would see an Aquaman movie. But I didn't think I would see an Ant-Man movie.
That's also good.
Right? If I were to pick another Avenger to see a movie of, I would have thought Hawkeye. Because he's been in all the Avenger movies.
I go to see Hawkeye.
Netflix series for Hawkeye.
As long as Jeremy Renner's in it.
Pretty sure they have one.
No way. I would have heard about it because Jeremy Renner's like one of my favorite actors.
Sorry.
Agreed to it.
They had one for Green Arrow. This guy's confused for a second.
But that's not Netflix. Green Arrow is on regular TV.
Is it? I thought it was on Netflix too.
Oh, really?
Oh, you can make a Netflix exclusive?
Yeah. All right. Vanessa, you good? All right, Bryce, hit us.
Alright, so it's 81. Well, 81 to the power of 0.75, which is also 81 to the 3/4.
3/4. Oh, I like where you're going. Does everybody have that so far? Sweet. Okay, Bryce,
So,
take us to the next level.
brackets, 4 goes to the index, square root of 81 to the 3rd.
Mm-hmm.
And then the 4th root of 81 is 3.
3 because it's 3 times 3 times 3 times 3. 9 times 9.
And then that to the 3rd power.
So that's 3
Yeah,
to the 3rd power, which is
9. I'm sorry. I'm sorry. A number, I can't. Slice it.
Can everybody do it?
I looked at the wrong number on my page.
Can everybody do that? All right. Now, guys, I know I've said it before. I'm not lying. Preeti, what is happening in your pre-calculus math 12 class right now?
Yes.
You're going over this. Okay? Well, no, they're just reviewing it. For you guys, this is the end of exponents. For her, it's like the baby beginning first step. Everyone's okay? If you can do that, you're a wizard. I'm not joking. You guys think I am. Regular people in the streets in Canada and the United States cannot do this math at all. Meanwhile, the guys from China are like, it's grade 4. The hell are you talking about? 8-year-olds back home are doing this. When did you guys do this? Come on, you can be honest.
I never learned it.
You never learned this? Shut up. Felix? Grade 8 or 9. Oh, we've almost caught up, guys. All right. Now, what have you noticed about all the examples up until now? They've all worked out, haven't they? 81 had a fourth root, right? Right? Is it always going to be that way? No. But here's the ticket, Andrew. If it doesn't work out that way, you get to stop. You either use your calculator or you don't go any further because it doesn't get any simpler. So, look at this. What would you do with this based on what we know? What would you write?
Square root of 8.
Square root?
Alright, so
Fifth root
I'm just used to
of
seeing
8
symbol.
to what power? 2. We know 8 doesn't have a fifth root. The biggest root 8 has is what? 3. Because 2 times 2 times 2. So this doesn't exist, does it? So we're cool. That's done. Unless the question says, evaluate. Then we got to use our calculators. How do I evaluate that? I just showed you when we were proving how to do this. What do you punch in? 8 exponent 2 divided by 5 equals. And that will get you a decimal answer. Does everyone see how it works? What would you write here to simplify it? 7, 7th root of 0.6 to what power? 15. How would you do this on your calculator? What would you punch in? 0.6 exponent 15 divided by 7 close brackets equals. Everybody good? Okay. Now, this is the last thing. I'm not even going to make you do it. The point of this question, I'm not going to make you take notes. I'm just going to show you one. The point of this question is double. 1, you have to understand how to work with formulas, which we already know because we did our measurement unit, right? And 2, you got to know how the exponents work. So the equation, the formula we have is this. Okay? B is the brain, and M is the mass. What do you know from this question? M or B? M. It's 27, yes? So, 0.01 times 27 to the 2/3. Do we know how to deal with that? We can do that in our heads almost now, can't we? That's the cubed root of 27 squared. Do we know the cubed root of 27? 3. Do we know what 3 squared is? 9. And 9 times 0.1 is 0.09. Now let's pretend you don't remember that. What you're going to do here is you've got 0.01, yes, times cube root of 27 squared. What's the cube root of 27? 3 squared times 0.01. 3 squared is 9 times 0.01. 9 times 1 is 9, and I needed 2 decimals. Does everyone see how it works? And then I would ask you to do the next 2, which you would do on your own. Is everybody cool? Okay, now listen to me. We're at a spot right now. We've got 35 minutes left in class. We're at an interesting spot right now. I'm going to shut up, okay? And here is what I want you guys to do. 2.2. What are you talking about? You would multiply that by 2.2.
Yeah, I know. It's 132. But
Yeah.
Yeah, so,
You're probably more than that.
yeah. Just call me fat. Say that should be 132 pounds?
No, I said you're more than that.
Yeah, you call me fat.
Anyway, guys, listen please. Listen to me please. Later in the period, I want to do some more of this work. Okay? All right? But before we go on, I want to show you, first of all, the complex exponent rules worksheet. I gave you all the answers to the basic one yesterday, yeah? Or the day before, I can't remember. It was yesterday. The honors class, nobody finished the complex one. They requested that I put the key for that on YouTube and they would mark it themselves. Is that what you guys want? Have you finished that page? No. So I'm going to do that, okay? I'm going to put that key online. All right? Now, this page. Please notice fractional exponents and radicals. I think you have it. I'm not lying. I think that you guys get this. I think. But I'm not sure. So if you're a little dodgy, make sure you do some of this. You can check your answer in the back of the book. Okay? I'm not going to actually assign it because I think you've got it. You were paying attention. Everybody was serious. I saw lots of notes being written. People answered questions. I think I'm comfortable. However, I'm not you. So if you're not comfortable, make sure you do some practice. Okay? So I'm going to shut up now. And I'm going to let you either work on the complex exponent rules sheet or fractional exponents, or if you're feeling really strong, take a crack at the rest of your notes. Because they look freaky, but they're not. Okay? Now,
I can't do that.
at about 10 minutes to 1, I'll give you back your test from yesterday. Okay? Now, a lot of you didn't do incredibly well. But I feel that you're probably going to be, you would do better after we just did these fractional exponents because we had to review radicals again. And remember, even if you did poopy, what's going to happen in like a week? You'll get the cumulative exam that will fix your grade. Everybody cool? Everyone cool? Okay. I got to turn off the screen because I haven't put your marks in to check my mark yet. I'm going to do that right now while you're working. You have 3 options of things to work on. So the majority of words that I hear out of your mouth should include phrases like root, exponent, multiply, subtract, add, right? Now, I'm not an idiot. You're not robots. You're going to talk about Wonder Woman's boots or whatever you're going to talk about. If you're not talking about Wonder Woman's boots, you're crazy because they were nice boots. What are you talking about? I liked her footwear.
Yes,
Anyway, you're going to do that because you're teenagers. That's okay. But please use this time to work. Because if you guys have yet to see it, you need to make the connection between doing actual work in class and getting rewarded with the only thing I can pay you with, grades. All right? The worst marks in this class, I could walk into this room without even looking at check my mark during your work periods, and I could point to the 10 worst marks in the room. Based solely on the fact that they do nothing when it's work time except talk to each other, not about math. I wouldn't need to see any of your work. I could pick you out of a lineup like that. Okay? If you don't care, I can't make you care. But if you do care, then use the time wisely. Okay?